Assalamualaikum and good day to all new students. Topic 1: Physical quantity and measurements. In this topic, we have three subtopic: 1.1, 1.2, and 1.3. In this lecture, we are going to discuss only 1.1 and 1.2. Meanwhile, 1.3 will be discussed in lab session. Learning outcomes. At the end of this topic, students should be able to define dimensions, determine the dimension of derived quantity, verify the homogeneity of equation using dimensional analysis, define scalar and vector quantity, resolve vector into two perpendicular components, illustrate unit vector in Cartesian coordinate, state the physical meaning of dot products, state the physical meaning of cross products. Dimension of physical quantity. Dimension is defined as a method used to describe a physical quantity in terms of its basic quantity regardless of the system of unit use. Okay, table show the dimension of the basic quantity. So as you can see in the table, basic quantity length SI unit is meter, symbol of dimension is a capital L. Okay, mass SI unit is a kilogram, symbol of dimension is a capital M. Another one is a time, SI unit is second, symbol of dimension is capital T. Electric current, symbol of dimension is capital A. Temperature, theta. Amount of substance, capital N. Luminous intensity, SI unit is a candela. A symbol of dimension is a capital J. The dimension of derived quantity. So as you can see in the table, there is a example of the derived quantity. First one is the area. Area is dimension is L times L. We have L square. SI unit is meter square. Second one is density, rho, mass per unit volume. As I said before, mass is capital M, volume is L3. So SI unit is kgm negative 3. Another one is momentum, P, mass time velocity. Mass is capital M, velocity is Lt negative 1. SI unit is kgms negative 1. Another one is velocity, displacement over times. Okay, displacement is length, so consider as L. Time is capital T. We have Lt negative 1. So SI unit is ms negative 1. So acceleration is velocity over time. Velocity from both, we have velocity is Lt negative 1. So you put here Lt negative 1 over time, then we get Lt negative 2. SI unit is ms negative 2. And force, pressure, work, power, as you can see in the table, and so on. Pure numerical factor, number like half, 3.5, pi, f, no dimension. Quantity can be added or subtract only if they have the same dimensions. Dimension analysis can be used to derive or check equation by treating dimension as algebraic quantity. Dimensional homogeneity, the dimension in each equation of both sides equal. So for example, we have an equation v equal to square root 2gh, where v is a velocity, g is a acceleration, and h is a height. So dimension of left hand side is v, V is a velocity. So displacement over time, displacement is considered as a L, time is a T. So we have a LT negative 1. Dimension of right hand side, we have a square root 2GH. As I mentioned above, 2 is no dimension, so we only consider G and H. G is acceleration. Acceleration is L over 2 square. H is a length, L. So we simplify this equation, then we get LT negative 1. So from this example, dimension of left hand side is equal to dimension of right hand side. So this, if this equation is same dimension, so we call it as a homogeneous.